Okie dokie. This is question 8. The binomial that's been expanded is 1 plus x. That's nice and easy. 1s, x's, easy numbers, right? And variables. To the power of n, we don't know what our n is, so this is different to other questions. What we do know is that the third term of this expansion would be 36x squared. Right. Like in the other questions, let's write the general term formula. Now, because it's the third term, instead of writing r plus 1, I'm going to write 2 plus 1. Okay, I get to this point and I go, oh yeah, of course, the r value has to equal 2 if it's going to be the third term, right? So in previous questions we didn't know what the n was, but in previous questions we didn't know what the r was. In this question we don't know what the n is, but we do know what the r is, right? So we've got n choose 2, because we've just discovered that r was 2. We've got 1 to the power of n minus 2, which is just 1, right? That's an easy number to work with. 1 to any power is 1. Times x to the power of r, x squared. And I know that this has to equal 36x squared. Okay? So therefore, n choose 2 has to give me my 36. Right? Let's just run through that. N choose 2, that's going to be some number. 1 to the power of n minus 2, that's just 1. I can ignore that. I won't cross it out, but you could, you know. X squared, yeah, I've got the x squared. All I need to worry about is the 36, and the only place the 36 can come from is this combinations number at the start. Right? So I've got to think, how can n choose 2 equal 36? And a way to solve this would be with trial and error. You know, so just say, okay, maybe start at 4. What's 4 choose 2? What's 5 choose 2? What's 6 choose 2? Eventually, you're going to find what n you need to get 36. Using your calculator and trial and error, that would be a valid method to use in a test, but you would have to show yourself doing the trial and error, if that makes sense. Now I think, 6 choose 2 is 15. 7 choose 2. 21. 8 choose 2. 28. 9 choose 2. 36. So you would have to write that out and maybe say found with trial and error. You still have to do some working out. I'm just trying to think. But trial and error is a valid way to solve maths problems, even in a test. Okay? I'm going to not use trial and error. I'm going to say, well, using combinations, that's what this is. N factorial, n minus k factorial, divide k factorial. Well, I've got n choose 2. So I'm going to go back to the original combinations formula that we used some time ago now. And I'm going to take all these k's and I'm going to make them 2's. And 2 factorial, that's easy. That's 2. And I know what I'm trying to get here. I'm trying to get 36. Right? So I've got, therefore, n factorial on n minus 2 factorial has to equal 36 times 2 factorial. So I've taken this 2 factorial, multiplied both sides. So I'm just left with the n terms over here. And 2 factorial is 2. 2 times 1. Right? So 2 times 36 is what? 72. Okay? Make a line in the sand here. Now if I've got n factorial, that means n times n minus 1 times n minus 2 times n minus 3, etc., etc. Right? Here I've got n minus 2 factorial, n minus 2 times n minus 3 times n minus, right? There will be some cancelling out between this term and this term, right? Maybe I can show that. I'll change the n factorial to this. N times n minus 1 times n minus 2, etc., etc., n minus 3, n minus 4, but I'm going to stop at the n minus 2 because then I can see this will cancel out with that. Right? So what's going to happen is n times n minus 1 has to equal 72. Okay? Something times something equals 72, and the two numbers, they're only 1 apart. This number here is 1 less than that. So at this point, hopefully you can see that n has to be 9, because you have to do 9 times 8 to get you 72. And you could solve it from there. You could say, all right, well, I can see it, because I know my 9 times table, 9 times 8, or my 8 times table. You know? But if you wanted to keep going with the algebra, you could. You could say n squared minus n, so I'm expanding, n squared minus n equals 72. Let's make it equal to 0 so we can solve it. Minus 72 equals 0. Now we can factorize this. We don't have to use quadratic formula. We can factorize it. We can say n minus 9, n plus 8 equals 0. Therefore n is 9. Well, there's two solutions here. N equals 9 or minus 8, but we're not Isaac Newton here. We're not going to be using negatives in our binomial expansion, right? So that's found. Now just check what the question asked for. It said the third term, find n. I've done that. And hence find the fourth term. Hence find the fourth term. Well, I think you could go ahead and do that fairly easily. Do I have room over here? Maybe. Hence fourth term, that will be r equals 3 now. So I will have, and I know what my n is. My n was 9, so 9 choose 3. 1 to the power of whatever, it's still 1, but 1 to the power of n minus r. So that'll be 9 minus 3, which is 6. And then I'll have x cubed, right? Because x to the power of r is 3 if I want the fourth term. Okay? So I would just need to know, well, what's 9 choose 3? And I've found this term. Again, that's a calculated job, and I think I've done that enough. And by the way, I think it's perfectly acceptable to leave it like this. Maybe get rid of the 1. 1 to the power of 6, just 1. But you know, 9 choose 3, that's a number. You can leave the term like that. You found it, I think.